All right, let's go over the four modes of heat transfer. First is conduction, and this is the direct transfer of heat through physical contact between two surfaces. So this is collisions of the molecules of the atoms that's transferring heat. The key variables involve temperature gradient between the two surfaces, the contact surface area, so the total area, and then the thermal conductivity of the material. So this is different for materials. For example, metals have a much higher conductivity than wood or plastics. An example in the athlete context is ice packs applied directly to the skin. So you have contact area, it's direct heat transfer through that contact, and you have high temperature gradient skin to ice. Uh, there are a lot of nuances onto exactly how much heat can be transferred based on physiological responses, but the principle of conduction applies. The second is convection, and this is when heat is transferred through the movement of a fluid or gas. So this is essentially an object and then some fluid medium. Could be water, could be air. So this is heat transfer into the air, into water, depending on what is flowing by it. The variables that will increase this are greater air velocity. So if you have air flowing at a higher rate, as well as larger surface area. This is why you see heat sinks with little fins. The other thing is the fluid medium. So heat transfers better into water than it does into air. So a practical example of this, of convective heat transfer, is using fans, or if you're in an ice tub and then you have the current and the water circulating through it, that keeps the fluid moving. So you get more convective heat transfer into the fluid, breaking up the thermal boundary layer when you're in the ice bath. Radiation is the third one, and this is the emission of infrared heat energy from the body to the surrounding environment. So this happens constantly. All objects that are hotter will slowly radiate. This is obviously where solar radiation comes. It does account at rest for a significant portion of heat loss, but during exercise in hot environments, when the body's at a really high level, it becomes a much minor, a much smaller, less significant form of heat transfer, and it's much harder to increase or accelerate heat dissipation from the body. A practical example, though, is training on artificial turf under sunlight. So different surfaces that you train on, you will notice that they emit a lot more heat. So there's a lot of heat coming off the ground. It's radiating. And finally, evaporation. The most important aspect of evaporation as far as athletes go is sweat. So the primary way that sweat helps to dissipate heat is by transferring heat through the skin in the form of sweat and then evaporating it into the surrounding air. Now, this is largely affected by ambient humidity as well as airflow and surface area. So again, environmental conditions largely impact the effectiveness of sweating. And this is why you'll see sweating is a lot less effective at dumping heat out of the body in high humidity, as evaporative cooling is far less effective as opposed to in a dry environment.